Daphne is a psychologist, and she wants to know whether the type of music a person listens to while studying will impact how well they learn math. Daphne believes that classical music will lead to better learning than rock music. But how does she find out if she's right? What should she do? Experimental design is the process of making decisions about how to run an experiment to answer a question. Essentially, experimental design is where a researcher decides how to actually find an answer to their research question. For example, Daphne wants to know if classical music will lead to better learning than rock music. She enlists volunteers and has half of them listen to rock music while studying and has the other half listen to classical music while studying. Afterwards, she gives them all a math test to see how well they do. If she's right, the scores on the math test should be higher for the people listening to classical music versus the people listening to rock music. Every element of Daphne's study, from gathering subjects to giving them the math test, is part of experimental design. Let's look closer at one type of design that can make studies like Daphne's stronger: matched subjects design. So Daphne has her two groups of subjects, the classical music subjects and the rock music subjects. And when she gets her results back, she realizes that her classical music subjects did better on the math exam than the rock music group did. Her study has supported her hypothesis. So that's it, right? Not so fast. You see, there's a problem. It turns out that the subjects in the classical music group have taken more math classes than the subjects in the rock music group. They're better at math, so how does she know that it was the music and not their knowledge of math that made them score better on the test? The answer is, she can't know. How could Daphne's groups end up so unequal? There are a couple of ways that Daphne could have assigned people to the groups. If she purposely chose to put people who have a lot of experience in math into the classical music group, that's an example of experimenter bias or researcher error. Usually, to get around bias and error in assigning groups, researchers opt to do random assignment. That is, they randomly choose who goes into what group, like flipping a coin. But chance could lead to Daphne's problem, even if she randomly assigned her subjects. Because of that, sometimes researchers choose to do a matched subjects design, or matched group design, which is an experiment where the subjects are matched based on a particular variable and then put into groups. By matching subjects, the researcher is creating equivalent groups for their study. Matching is almost always done by looking at a variable that could affect the dependent variable. In Daphne's study, the dependent variable is score on the math test. She might want to match people based on their age, since older students will have had more math classes; major, since math majors will presumably score higher than English majors; IQ, or another measure. Remember when you were a kid and had to split up a pile of something like candy? You'd pass one to the other person and say, "One for you." Then you'd put one in your own pile and say, "One for me." You'd keep doing that until all the candy was passed out. Matching subjects is kind of like that, except the candy is subjects and the piles are experimental groups. For example, let's say that Daphne chooses to match her subjects based on major. She takes two math majors and puts one of them into the classical music group and one of them into the rock music group. Then she takes two English majors and does the same thing. She continues to do this, matching subjects based on major and then splitting them up into groups until all the subjects have been matched and assigned. There are several strengths to matched groups design. The main strength, and the reason to use it, is that it helps to make sure that the two groups in an experiment are equivalent. If Daphne is matching based on major, she knows that she won't end up with all the math majors in one group, which could happen if she randomly assigns subjects. Another strength of matched subjects design is that it requires fewer subjects to be reliable. If Daphne randomly assigned subjects to the two groups, she'd have to have a large sample in order to assume that the two groups were equivalent. But with matched groups, she doesn't need as many subjects. Despite the strengths, though, there are some limitations. For one thing, how do you know which variables are relevant? Daphne chose to match her subjects based on major, but what if major isn't affecting her variable? What if, instead, the overall GPA of the student is affecting whether or not they do well on the math test? In that case, she'd be better off matching for GPA, but there's no way to know which variables are relevant and which aren't. Another limitation of a matched subjects design is that some potential subjects will have to be left out of the study because they don't have a match. For example, what if Daphne only has one art history major? She can't use that person as a participant because she doesn't have another art history major for the other group. But that person could tell Daphne something important about art history majors, math, and music. Experimental design is the way that a study is planned in order to answer a research question. One important type of experimental design is a matched subjects design, also called a matched groups design, which is when subjects are matched on some variable that might be affecting the dependent variable, and then split into two or more groups. Strengths of the matched groups design include the fact that it creates equivalent groups, and that it requires fewer subjects than a randomized design. However, there are limitations as well, including choosing relevant and important variables, and leaving subjects out because they don't have a match.